Welcome to this video about how to make a graph in Java. We'll make a graph based on this drawing here. You can see we have 4 vertices, A, B, C and D, and 5 edges. Each edge has a weight, which is the cost of going from A to B or D to B and so on. We also have this coordinate system, so each vertex is actually represented by a point, a Java point, which has an x and y coordinate. Okay, so we need to make 2 classes. One edge class to hold these 2 vertices in the weight, and then one graph class which will hold all the vertices and all the edges. So let's make the edge class first. We'll make a new class here called edge, and we're going to make it so clever that we will be able to handle all different types of objects, not just point, and we'll do it generically. So I have this type parameter t here, which means that whenever we make a new object of type edge, we can assign whatever type this t should symbolize. And we will have 3 instance variables. One is called from vertex equals null, and the next one is going to be to vertex. The last one is going to be of type integer, weight equals null, which will be the weight from vertex. Okay, so I'm going to make a constructor here. Okay, pretty standard stuff. So we need to make actually a method so we can add edges to the graph. And of course we need to make the graph also. So this is actually everything we need here. You can see these are public still, so we can access these just by dot notation. Okay, so let's make then the graph class. Called graph. And it's also going to be generic, so it has to have the type parameter t. This class will hold one special instance variable called an adjacency map. And it's kind of special, so it's going to look like this. It's going to be a hash map of actually a t will be the key for this map. So what we'll do is what we will, whenever we make an edge, we will first give each vertex a map of its own. Okay, so there will be 5 maps for this particular graph. Okay, so and each entry in this map will then be another map, and that will map all the different edges originating from this particular vertex. So the first entry in the outer map, which will have the key A, will then get 2 entries in the inner map. One entry for the edge going from A to B, and one entry for the edge going from A to D with the weight 5. Okay, so there are two maps, one outer and one inner. And the inner map is going to be of the same type, hash map. And this will have the key of t just as the other one, but the value will be integer, because that will be the weight of the edge. And we'll call this adjacency map equals new map here. So we'll just get rid of some of this stuff here. For example, that one. Okay. And this should be private. And we will do a getter method so we can access it. And we will delete this setter that I just generated, like that. Yes. Okay. So we will now make a method called add edge, which is public void, which is will be able to take an edge object of type t called edge and add it to the graph. But as you can see, the map doesn't store edge objects, it stores only t objects. So we need to unpack this edge object and get the values that we defined here to get them unpacked. So we'll get a t from vertex. Basically I can just copy this one because it's just the same here. Just copy this, it's easier. And then say that this will be edge dot from. This will be edge dot to vertex, and the weight is going to be edge dot weight. Yes. Okay. So now we're going to call on a private method that will execute the insertion actually. So we'll say add edge with from vertex to vertex and then weight. But since this method does not exist yet, we can hover over it and just click this nice wizard here, and it will create the method for us. That's nice. Map. So we have both an outer map and an inner map, and we will insert this into the inner map. But we first have to check whether or not we even have an inner map for each vertex. And to begin with, we have no inner maps, so we have to check it. So we will say if not adj map contains from key from vertex, which means there is no map, there's no inner map yet. Then we have to create such an inner map and put it into the position for the key of from vertex. Yeah? So we'll say adj map put here, and the key will be from vertex, and the value will be a new map which looks just like this here. New map here, and that will be new in front of this one, like this. Now when we have made this if statement, we are sure that there exists an inner map. Okay, and then now we can insert the two vertex and the weight as entries in the inner map and give that the key from vertex. Yeah, so we will say at adj map get using the index from vertex here, and now we have the inner map that we just created. We just created it here, and we can now say put, because we have the map, and the key will now be the to vertex, right? Because this will say that we have a link between from and 2, and the value is weight. Yeah? Okay. See, now we're halfway, because the graph that we work on is undirected, which means it does not know direction. So A and B are linked together, which means that you have to go both ways, both from B to A and A to B. So we need to insert the reverse direction here, and we need to do it just the same way as before. So we can just copy these two lines, three lines, sorry, and then replace the vertices, right? So I'll change from to 2 and from to 2 and 2 to from, like this. And the weight is the same. That's it. So now we have made our method, which is called here, actually. Yes. So take a look at the next video. There I'm gonna make a breadth first search iterator and also demonstrate that we actually do visit each vertex once. Thank you.